Okay, we're recording now. So I'm going to repeat that. Here's the Data Science Lab Moodle. I've uploaded the day one video recording to YouTube, so you can access that here. I've also updated the Jupyter Notebook files of the tutorials. So if you have access to Moodle, I encourage you to go in here right now and actually download today's Jupyter Notebook and follow along. So here's the Jupyter Notebook for yesterday and for today. And you can just click on it and then it'll prompt you to download. So you can download it and then you can run it wherever you're going to run Jupyter Notebooks. I mean, you can open Jupyter Notebooks and access it. So I encourage you to do that. We have a chat. Okay, and I'll try to talk a little bit louder. Also here in, oh, okay, so that's the Moodle. For the repository, I've also updated the day 2 list and dictionary just a few minutes ago. So if you fetch origin, if you pull the Python 101 repository, you should be able to also access the today's notebook this way as well. So these are two ways you could access the Jupyter Notebook that I'm going to be using today. This FYI, if you don't have Moodle, but you still want the YouTube link, the Jupyter Notebook folder file I have also updated. So this is the day 1. This is the folder we used yesterday. And at the top of the folder, I also included this video recording, the link to the YouTube video. So even if you don't have access to Moodle, but you do have the GitHub, then you can get the link here. And I'll also put that, this is today's Jupyter Notebook. I'll upload, once I upload it to YouTube, I'll include the link in here as well. So, okay, so any questions with housekeeping before we move on? Okay, let me give you a minute to, who is downloading the Jupyter Notebook for day 2 right now, either from Moodle or GitHub, and is going to use the Jupyter Notebook alongside of me today? Great, I really encourage you to do that because today I have included a lot of exercises. So in between the different parts of the tutorial, I'll be asking you to code as well to come up with your own solutions. So it'll be great if you can do that on your own and then kind of practice. So, okay, if you're not able to do that, please message me one-on-one afterwards and let me know if you have any trouble, like, you know, installing Jupyter Notebooks or whatnot. So, okay, so let's move on with the tutorial then. So today, we're doing Python 101, data types and control structures. Today we're looking at, yesterday we looked at primitive data types like integer, float, Boolean, and string. Today we're looking at non-primitive data types, which are more complicated data types, list and dictionary. Non-primitive data types means data types which are constructed using primitive data types. So, so we talked about the primitive data types yesterday. Today we're talking about non-primitive data types, list and dictionary. And then tomorrow and Thursday we'll move into control structures such as if and for loops, while loops. So a quick note on some common sequence types in Python, some common non-primitive data types in Python. These are the, I would say, the 3 most common. So using these square brackets, we have list, using these curly brackets, we have dictionary, and using the curved brackets, we have tuple. So today I'm only going to talk about list and dictionary, but tuple is another similar sequence type that's used in Python. But just so you don't get confused, these square brackets, curly brackets, and curved brackets indicate different data types. So unlike the quotes where you can get away with using like single quotes or double quotes, with brackets, you have to be very specific. If you're using square brackets, you're making a list. If you are using these kind of curly brackets, you're making a dictionary. So these cannot be interchanged. Okay, so let's talk about lists. Here's a link to some relevant tutorials or information about lists and data structures. Okay, so there are a few ways to create lists. One way you can create an empty list is using a list comprehension. Like this. So you can define a list called fruits and set it equal to an empty list like this. And if you do that, you'll get an empty list. Okay. And you can also do this. You can also create an empty list using the list function like this. And it also creates an empty list. So these, we're going to talk a lot more about list comprehensions and the list function probably in a later tutorial. But I just wanted to let you know this is called a list comprehension. This is called a list function. So here's a list constructor here. You can also create a list containing elements. So here we'll create the list fruits, and this list will include orange, apple, pear, banana, kiwi, apple, banana. Okay. So, and now I've instantiated that list. And you can already see with lists that lists allow duplicate items. So you can have the items in the list do not have to be unique. You can here this list has 2 apples and 2 bananas. Okay. So let's cover some indices, talk about indices on lists. We did this yesterday with indices on strings. It's very similar. It's identical actually. So we have our fruits. Okay, if I indicate fruits 1, what's that going to return?
Apple.
What's that?
Apple.
Yes, that's right, apple. Because our lists begin with a 0 index, right? So fruit 0 will give us what?
Orange.
Right. And what's fruits 2 through 4 going to give us?
Apple and pear. Apple, pear. It will not include banana?
No, I think it does not include kiwi, and then it's like gonna be pear and banana.
Yeah, apple, pear, banana.
So
no apple.
No apple, right? Because orange is index 0, apple is index 1, and so index 2 is pear. So this is going to give us. Remember, this notation is a little confusing. It includes 2, excludes 4. So this is going to give us 2 and 3. Right. So which is pear and banana. So this notation is basically saying give us from pear up to but not including kiwi. So it excludes kiwi. So this is going to give us pear and banana. Okay. What is this line going to give us?
Length of list.
So this length of fruits here is going to give us the number of elements in this list. How many elements are in this list?
Would be
So there are 7 elements in this list. So what's this going to give us?
Error.
Yeah, this is going to give us an error because there's 7 elements in the list, but they're indexed starting with 0. So index 7 is out of range, right? So the highest index that we can do for fruits is the length minus 1. So what's this going to give us?
Banana.
Yeah, so this is going to give us banana. So this is one way to index the last element of a list, is to say to index the length of the list minus 1. Right? But we know a shortcut for that is just to index minus 1, right? So that's also going to give us banana. Okay, and we talked about this. What if we leave the right-hand side open? So fruits 4 to undefined is what's that going to give us?
Apple and banana.
Right. So 0, 1, 2, 3, 4. So what are we gonna get?
Kiwi.
Kiwi, apple, banana.
Yeah,
Kiwi, apple, banana.
it's gonna give us the 4th index and then everything else to the end of the list, right? So kiwi, apple, banana. And what about this? What if we specify a number at the end of the list, which is much, much larger than the list length?
Error.
Error.
So remember, if we index a number that's too large, it will give us an error. But these index slices are handled differently. So if you index something that's out of range, it's just going to ignore it. So it's just going to treat it like this. Okay. So for some reason, unbeknownst to me, if you include an index that's out of range, it will return an error. But if you return a slice where part of the index is out of range, it will just treat it like it's the end of the list. And what about this?
2 dots.
Yeah.
Empty.
0, empty.
Yeah, this gives us an error in fruits if the index is out of range, but this just is treated more generously, more kindly. It just returns an empty list, right? So that's just a kind of a quirk about Python. Sometimes it returns an error, sometimes it just returns a null value. Okay. We also used the in operator yesterday on strings. So you can also use the in operator on lists. So here's our list of fruits. And you can test, is kiwi in fruits? And this returns true. Well, this is a great way to, I mean, this is very useful when you're doing data science. When you're writing if statements, continue with this statement if something is in this list, right? So what's passion fruit and fruits? What's this going to return?
False.
False.
Yeah, no passion fruit in our fruit basket, so false. What about this statement? Passion fruit not in fruits.
It's true.
Right. Right. And what about if I move the not to the front?
True.
True.
Also true. So this not statement, when you're using not within, not can be used with the in operator to negate the in, right? To be not in, or not can also be used with the with a truth statement. So passion in fruits returns true, and then returns false, and then not false returns true. So not here is actually quite useful. It can be used in either location. Okay, what about this? We have a kiwi in the fruit basket. We have an apple in the fruit basket. Do we have the list kiwi and apple in fruit? What's this going to return?
False.
Yeah, this is going to return false because this data structure is a list containing kiwi and apple. We have the string kiwi and we have the string apple, but we do not have a list containing kiwi and apple in this list of fruits. So so actually these exercises should be up here. Let me okay. So let's take a minute, right, and try these exercises. So write a statement confirming that kiwi and apple are in fruits. So take a minute to do, I'll give you about 30 seconds to do that. And then you can share that in chat if you want, or you can say it out loud. Yeah. I'm going to number these. Okay. Okay, so let's try that. Kiwi and apple. Okay, yep, that works. What about this? Will this be true or false?
False.
It's true, right? The reason why this is true is because this statement right now is not doing what we think it's doing. Okay. So you actually can't use the AND operator to join these two objects. Okay. So what's happening is in this statement, you're actually evaluating apple and fruits, which is true, and some object. And the Boolean logic of Python, this is a strange thing to do, but when apple and fruit, this is true. And when you test whether that's also like true with an object, objects are treated as true values, right? So I think that none values are treated as, well, I don't know. Okay, but anyways, so that's why this passion fruit and apple and fruits is also returning true, because you're actually testing the truth of apple and fruits, which is true. Apple is in fruits, and the truth value of an object. And Python just treats this as a true statement, right? So this is actually not giving us what we want. So do we, any other way to test this? Yeah, so Altanai, that's right. So you're going to have to test these separately. So you're going to have to test and then join them with an and, right? So kiwi, so this is testing kiwi and fruits and apple and fruits separately. And this is going to give us true. And we can verify this if we switch passion fruit here, right? What will this return? Yeah, this should be false because passion fruit and fruits should be false. Right, so that's false. So this is a little tricky. You can't use the and operator with in this way. Okay. Okay, so what if we want to write a statement confirming that whether kiwi or star fruit are in fruits? Go ahead and upload your answer to chat if you like. Great. Great. Yeah. So here kiwi or star fruit, so we can just replace this with star fruit. And with this return, what will this return?
True.
Yeah, this should return true because with the or statement, only one of these has to be true, and kiwi and fruits is true. So that's true. And how can we write a statement? I want a statement that's going to return true if we can confirm that kiwi is in fruits and that tomato is not in fruits. So for exercise 3, I'll give you a second. Okay, so Adil, I think that one's gonna have. Yeah, so I think Adil's answer is interesting. So Adil wrote this one, right? And this is gonna give us the same problem that this gave us, right? So this is gonna return true, but it's actually testing not tomato in fruits and kiwi, right? And we can show that this is not right because we can also check passion fruit and not tomato in fruits, and that should also give us true, but that's not what, but actually passion fruit is not in fruits, right? So so let's see. Let's see what other yes. Right, Adil, let's see, Alina and Gulner, yes. So this statement, kiwi in fruits and tomato not in fruits, this is going to work. Another way to write this, again using the not, is to shift the not to here. So we can test kiwi in fruits is true and tomato in fruits should be false. So if not this, that's also fine. So this should also give us true. Okay, so either of these are fine. So you just have to test this when you're coding this yourself. If you're making complicated truth statements or Boolean statements, you want to make sure that the logic is giving you exactly what you want. Otherwise, you're going to be selecting the wrong subset of cases to look at. So, okay, great. Okay, moving on. So you can also concatenate lists. So concatenating just means adding them together. So here's our fruits list. Here's our list of vegetables. Right, so that returns this, carrot, cabbage, carrots, and asparagus. And we can add these. So if you use the add operator on two lists, it will just add the two lists, the elements of the two lists. It will combine the elements of each of the lists, right? And again, here we have 2 apples and 2 bananas. And in this concatenated list, we still have 2 apples and 2 bananas, right? this is the only reason why this is long instead of wide is because it wouldn't all fit on this one line. So you can also multiply lists. So 3 times vegetables, that's going to give you cabbage, carrots, and asparagus in a single list 3 times. Cabbage, carrots, asparagus, cabbage, carrots, asparagus, cabbage, carrots, asparagus. So, you know, we could combine this. So you have fruits plus this triple vegetable list, right? So you can do that. Right, so you've got the cabbage, carrots, asparagus 3 times. Okay, what's this going to give us?
Error.
Yeah, this is going to give
Vegetables.
this is going to give us an error because for these list concatenations, the plus is supported, the multiplication is supported, but the minus is not supported. Right? So if we want to remove items from a list, we can't do it this way. We're going to have to do it a different way. Okay. And I don't even know what I can't even imagine what division would be. So I guess that's going to give us an error. Yeah. Okay. So so let me introduce some basic functions. So far we've talked about using the in operator, using these indices, right? And how to construct the list. But there are a lot of other things we can do on lists as well, using list functions. So again, check out the link at the top if you for more information about these. So all of these Python data structures, more on lists, using, so these append, extend, insert, remove, pop, these are a lot of the functions we're going to look at now. But this is a Python tutorial you can look at that has some information about that. Okay, so let's go over some of these. Okay, so we've already talked about this. The length function gives us the number of, well, let's just see what's in our fruits. Okay, so there's fruits. The length we've already done. Checked is 7. Okay, the count function lets you choose an element and it returns the number of times that it appears on the list. So apples, there are 2 apples in our fruit basket, in our fruit list. Append adds an item to the end of the list. So if you append dragon fruit, you can do that. And now dragon fruit's been added to the list. One way, this is a very common way when you're doing data science, or like, you know, adding elements to the list as you kind of process some data. You can create an empty list and then append elements later. So very commonly, I'll just, at the top of my code, I'll create a new list, say new fruits, right? Just an empty list. And then as I'm doing analysis, I'll add, I'll append watermelon, I'll append tangerine, and now, you know, it has watermelon, tangerine. So this is, this append is a pretty common way to instantiate your list, right? You start with a null list, an empty list, and then you append lines as needed. So I normally just use append. You can also, and this adds it on to the end of the list. Usually when I'm using lists, I don't care about the order, but if you do care about the order of your list, you can insert an item at a given position. I won't say I don't recommend this. It's just you can do this if you want. So again, double check that let's see. So fruits, here's our list of fruits. And if you run insert 2 watermelon, this is going to insert watermelon at the number 2. So orange is 0, apple is 1, pear is 2. It's going to insert watermelon between apple and pear. Okay. So now you've got orange, apple, watermelon, pear. It just shifted everything down from pair on. So you can choose like the index where you want to add it. You can also, okay. Okay, so the remove function removes the first instance of the item. So we can remove orange. Right, orange is here. Actually, let's remove apple. So if you remove apple, what's our list going to look like?
It will remove the first apple.
Mm-hmm. So now our list here, we had orange, apple, watermelon, pear, and we had another apple after kiwi. Here we still have that apple after kiwi, but remove the first instance of the item when counting from the beginning of the list. So orange, apple, watermelon. Now we just have orange, watermelon. Okay, so let's add some more apples. So I'm going to add 3 more apples, and now these apples are off the bottom of the list. Okay, so the pop function removes the last item of a list or at a specified position. So if you want to remove, if you run this fruits pop, it's actually going to return that last item, apple, and it's also going to remove it from the list. Right? So this is a great way to kind of move through a queue or a stack. You can use pop to simulate a queue or a stack structure to remove items at the end of the list, as you know, kind of remove them as you process them, or from the beginning of the list or from wherever. Okay, what's pop 1 going to return?
Watermelon.
Yeah, it's going to return watermelon because that's the item at the specified position, at the index 1 position. So it returns watermelon, and the list of fruits now is going to not have a watermelon. You can also reverse your list in place. Reversing your list in place means it returns the reverse list and it saves that. So you can and now our list has been reversed. So that's the reverse function. There's the sort function, which sorts items in place. So in place, this in place word, in place is really important. It means that it's sorting the items, the thing that it and it's going to save, kind of update your variable with that new sorted list. Right? So this is really important when we talk about pandas, because this kind of functions in pandas, if you type something like this on a pandas object, like a database, it will return a sorted version of that list, but it will not save, update the database with that sorted list. If you want to do that, that's an additional step. So these ones do it in place. So they sort it and they save the variable with that new sorted. So if you sort, now you're going to have the same list, but sorted alphabetically: apple, 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 banana, dragon fruit, kiwi, orange, pear. All right. And you can also sort in reverse. So the sort function, if you look here, down at sort, it has the parameter false, so reverse. So the default for this parameter, if I don't include this parameter reverse in my function, like here I didn't write reverse, then the default is false, which means I don't want the list sorted in reverse. I want it sorted alphabetically. But if you include that parameter in the function and you define it as true, now it's actually going to sort in reverse order. So now they've been sorted in reverse order. Okay. I'm going to create a new list called fruits2. It's the same as fruits1. And I'm going to use the clear function. Removes all elements from the list. Okay, so fruits 2 is clear now. But let's just double check. What about the original fruits? I just defined fruits 2 as fruits, and then I cleared fruits 2. I removed all the elements. What's this going to give me?
I think it should remain the same list.
So this is tricky, right? Different programming languages handle this different ways. It's empty. So here, when you assign fruits 2 to fruits, it's actually assigning fruits 2 to the values which fruits is also assigned to. And when you remove those from the list, it also removes them from fruits. So this is something to be very careful about if you're copying a list or copying some data structure and then you delete it or you remove items from it. You have to be careful about, you have to be very clear whether you are also removing items from the copy of that. And we'll cover this more in a second. So, okay. So here are a few exercises. Write a statement confirming that there are at least, so here's, let's take fruits again. Well, let's see, fruits, what do we have in our fruit basket? Sorry. Okay, that's, oh, so we need to reinstantiate it. So I'm gonna copy and down here. Okay, so we reinstantiate fruits. I'll put it, okay. So first thing, let's write a statement confirming that there are at least 4 apples and fruits. So testing whether there are 4 apples and fruits. So how can I do that? Great. So perfect. So we can do, we can test how many apples are in there. And then if we want to test if there are at least 4 apples, then we can use the, right, perfect. The greater than or equal to 4. And that will be false because we only have 2 apples in there. Okay, if there are fewer than 4 apples, then let's add some apples and then confirm that there are at least 4 apples. So how can we do that? So first one, let's use append. And for the second one, let's use concatenate. Use append to add apples. So if we're going to use append, yeah, how can we use append to add some apples, at least to get up to at least 4 apples? So how are we going to use append, the append function, to add some apples to fruits there? Okay. Okay, so we've got this, we've got this. Okay, so for append, actually, I'm gonna move this one down. So for append, that's right. We can run this, and now we've got it added another apple. Is this true? Not yet. We can run it again. Run it again. How many apples? True now. Right? We have 4 apples. 1, 2, 3, 4. Okay. So we can run this a few times, or we can just copy it. Right? So that's what we did before. How can we use list concatenation to add apples? So here's a solution that somebody put up. This is I think this is the right idea for the list concatenation. But if we're using list concatenation, then we don't need the append function. So what's the correct code for this if we want to add in 2 apples using list concatenation? Any ideas about how to concatenate these 2 lists? Great. Yeah, Salia suggested the plus. So yeah, basically we're just gonna add the plus in here. And that's gonna add 2 more apples to our list. Right. But did it add 2 more apples to our list? Okay, so here's fruits plus 2. So let's just double check this real fast. So fruits is this. Fruits plus apple gives us this. That's right. So, but what does fruits look like now? How many apples are in fruits now?
6.
4. What happened? What does fruits look like? Fruits still looks like the original fruits. Right? We added in these apples. Why does fruits still have 4 apples and not 6?
Oh, then probably since those 2 apples are extra ones that are out of fruits list.
Okay, yeah, maybe they're bad apples. No, so the problem here is in the command line, all we asked Python to do was to take fruits, add in 2 apples, and return that, which it did. Right? But we did not update fruits as this new object or this new list. So if we want to save this output as fruits, then we have to actually assign this to fruits again. So fruits will be equal, right? No, that's right. So we need to reassign fruits as fruits plus apple. And if we do that now, oops, sorry, I didn't run this. Yep, now we have 6 apples. Yep, and we can confirm that it's actually greater than 6. Okay, so this is really important. Again, this is the same idea as in place, right? We did this, but we didn't. This statement does not change the value of fruits. Right? All this does is add 2 apples to this list and output it. but it doesn't save that output anywhere. So if we want to save that output, we actually have to reassign it to fruits or some other new variable. Okay, so Sanat asked about plus equals. I'm not sure because I know that's possible in Java, C++ or Java. Let me see, plus equals. I'm not sure if that syntax is supported for Python. Yeah, so the plus equals syntax here is equal to this, right? So this is a syntax saying take this variable, add this thing to it, and save it back to that variable, kind of update it. So yeah, so good call, Sana. So you can, I mean, this and this are identical. It's just an kind of an abbreviation. This notation was pioneered in C++ computer language, but I think it seems like Python's adopted it too. Okay, so how do we get down to write a series of statements ensuring that there are one and only one apple in fruits? So take a second to do this. For now, because we don't have loops, we have to do everything like one at a time. Yeah, so we have to delete apples. So how can you, I want to ensure that there's, so it 2 steps, remove apples. And step 2, verify that there are one and only one apple in fruits. So this is some statements to remove apples, and this is some statements to verify one and only one apple. So what's the fastest way to do that?
Maybe using pop and then specifying the positions of apples.
Okay, great.
Maybe
So,
sorting.
so we can do remove apple. One thing we could do is just like keep running this. How many apples? We still have 6 apples. 5, 4, 3, 2, right, 1. You could even do it again. Do it again. No more apples. Now let's append 1 apple. Okay, and then right, and then to test, another way to write this would be we could just redefine the variable, right? So redefine the list. It's kind of cheating. Let's delete it. Okay. And then to verify that there's one and only one, how would we do that? So I think this is similar to something else that we've done. Yeah, perfect. So fruit count, apple equals 1. Okay. So great. I wanted to mention, like when we're copying a list. So we had the problem up here when we used clear, that it not only cleared one list, but it cleared the other list that this was used to create that second list. So here, I'm gonna cover a couple of different ways of copying. So here we saw, if you copy like this, and then you pop an item from fruits, we popped one banana from fruits. It also pops that item from fruits too, right? So here, like assigning this, and then if you pop something from one list, it pops it from the second list. What if so another way, this is one way to copy a list. Here's another way to copy a list. You can use the copy function. Fruits2 equals a copy of that. So let's do that. And now let's, and if we pop kiwi from the fruits list here, now we have that list minus kiwi. What about fruits? Did that pop the kiwi or not when we use the copy function? The answer is it did not pop it. Right. So so copy gives like a shallow version, right? So here, and another way to do this is assign a new variable to the values of the old one. So let's do fruits2 equals this. So this is slightly different. So here, fruits2 is orange, apple, pear, banana. Fruits is also orange, apple, pear, banana. And if we pop fruit, this pops banana from fruits. What about, so fruits is now one banana down. What about fruits2? Is that going to, oops. So we found two ways. If you assign a variable, if you create a new list from an old one using this notation, it's not going to save these to the same spots. It's going to take the values from this and save those somewhere else in this variable. And then if you manipulate one, it's not going to affect the other one. Right? That's also true if you use the copy function. It creates a shallow copy. If you affect one, change one, it does not affect the other. However, if you assign with the equal sign, and then when you change one, it's going to change the other. So be very careful, like when you're using equals versus if you don't want to, if you want to make changes to one and not affect the other, then don't use the equal sign to create the new list. You have to do it a different way, either using the copy function or this way. So that's just a note on that. Okay, so we're done with lists. Let's move on to dictionary. Here's some references that you can check. Okay, so a dictionary, there are three ways to construct a dictionary, again, with the comprehension, like just like we did with the list, but now instead with the curly brackets, this creates an empty dictionary. Or you can use a dictionary function like this, just like we did with the list function, and that also creates an empty dictionary. More on those later. Or you can construct a dictionary using key value pairs. So this is a dictionary has a different data structure. It has a different structure than a list. A dictionary is a list, but of key value pairs. So you can see here, and they're separated by commas. So here you have the key is Coke and the value is cola, and that's one pair. And now you have the key and value of Sprite and soda separated by a colon, and that that's one key value pair. And then Piala its value is tea, and Starbucks has the value of coffee. So if we construct it this way, this is the dictionary, right? So it's got four key value pairs separated by commas, right? So this is a dictionary structure. How do you access data in dictionaries? So you can specify a key like this using the square brackets. So now, although this dictionary is defined using curly brackets, when we're using the square brackets here, it's to specify that we want to access an element. We want to index some element in that dictionary. So here, if I write beverage and I specify the key, right? The key is Coke. It's going to return the value. So the value of Coke is cola, so it returned cola. So dictionaries are kind of used as they're kind of called a matching type. Yes, they are a sequence in that they have a list of key value pairs, but the way that the kind of strength of the dictionary is that you can insert a key and it will return the values. It's kind of a lookup, kind of creates a lookup. It's a lookup table or lookup structure. What's this going to give us?
Sprite maybe.
Yeah, we'd want it to give us that, but dictionary actually is not indexed by numbers. So so this is going to give us an error because dictionary is not indexed numerically. Dictionaries are only indexed by these keys. So essentially, Coke, Sprite, Piala, Starbucks, these keys in the key value pairs, that's the index. The index is the key, the set of keys which you specify. Right? And so this Coke is the index of the Coca-Cola key value pair. And that's how you can access that index value of cola. But dictionary, you cannot use numbers to access elements of a dictionary. Okay, so what are some basic functions on a dictionary? Well, we have these keys here, right? Coke, Sprite, Piala, Starbucks. We can use the keys function to return a list of keys or keys. So it returns Coke, Sprite, Piala, Starbucks in a list, but this list is cast as a dictionary keys object, right? So this thing, if you look at the data type of keys, right? What is this data type going to be?
List.
So actually the list is here. This is the list, Coke, Sprite, Piala, Starbucks. However, this list is being cast as the type dictionary keys. So the data type of this returned by this function is the data type dictionary keys, which is not a list. However, the list is in there and we can get it by casting this data type as a list. So here we're actually going to use the list function, which I talked about before, right? If you cast this beverage keys object as a list, that will return the list, right? So you can see the difference here. When you run beverage keys, it returns this list, but cast as a dictionary keys object. But if you recast that as a list, it'll just return the list, right? And now we can save that to a new variable called bev keys, which is a list, right, of the keys of that dictionary, Coke, Sprite, Piala, Starbucks. So Coke, Sprite, Piala, Starbucks. The values function does the same thing, but with the dictionary values. So the values here are cola, soda, tea, coffee. So you can use the values function. Here. Same idea, right? It's a list, but this list is cast as a dictionary values object. So if you recast that object as a list, then you just get the list, cola, soda, tea, coffee. We can save that to a new variable called bev values, and that variable will be a list of the values. Okay, so we've got the keys function, we've got the values function. There's also the items function, which returns key value pairs. So this the items, it returns a kind of a complicated data structure. So it returns a list where the items in that list are parentheses, Coke and Cola, Sprite and soda. What is this data type right here that I've highlighted, Coke and Cola? What is that data type? So Coke is a string.
Is it tuple?
It's a tuple. Yeah, Coke is a string, Cola is a string. These two strings are separated by a comma and they're wrapped in curved parentheses, which I mentioned at the beginning of the tutorial. Are a tuple. So it's actually giving us a list of tuples. I'm not going to go into detail about what tuples are, how to use them, but here you see it's returning a list of tuples, right? So we've talked about lists, we've talked about dictionary. Now tuple is making an appearance, but I'm not going to cover it in detail here. Right? So what is this data structure? It's a list of containing 4 tuples, and each tuple contains 2 strings, the key and the value. And then that structure is being recast as an object called dictionary items. So it's a little bit complicated, but I could access that by recasting it as a list if I want. And that will give me the list with the 4 tuples, right? And if I save that as a list, right now, if I index this, what's bev item 0 going to give me?
Coke and Cola.
Yeah, it's going to return the first item in that list, which is a tuple, Coke and Cola. What's this going to give me?
Two times Coke and Cola.
No, good guess. This is so here I have nested structures, right? I have nested sequences. I have tuples inside of, yeah, it's going to give me Coke. So here I have tuples inside of a list. This gives me the first tuple. This is going to give me the first item, the first string in that tuple, which is Coke. So this is how you can parse items out of nested sequences, nested lists, nested, lists of tuples, tuples of lists, dictionaries of lists, lists of not dictionaries of lists, but lists of dictionaries. Okay, what's this item? What's this going to give me?
Starbucks.
Coffee.
Oh yeah, coffee. It's just one.
That's right. So it's going to give me the third indexed tuple. This is 0, 1, 2, third indexed, the third position, and the first position in that is coffee. Okay, great. Okay. Okay, what about, okay, so the get function is another way to return a value. It's the same as, it's identical to checking the index like this. The pop function, the dictionary also has a pop function, and it removes an element with a specified key. So for a list, if you run pop, remember, it removes the last item of the list. For dictionary, we don't have the last item of the list. Well, I guess we do, but it's you have to specify the key. So we can pop Coke, and it's going to pop that key value pair. So now beverage just has Sprite, Piala, Starbucks. You can use pop item. That kind of does what we wanted it to do. It removes the last inserted key value pair, which is going to be Starbucks and coffee. And so now you can see that just has two beverages. What if we want to add a new key value pair? So the easiest way to do this is to write the new key here to indicate the new key, and then indicate what the value is going to be, like this, coffee. So right now, Starbucks coffee is not in our dictionary, but if you write it like that, now it is. You can also specify a null value. So for example, let's say Fanta, but I don't know what the value is yet. I can write this, just a null string or an empty string. And now Fanta is in there, but it just has a null value. Right? Can we add the same item twice? Remember, in lists, you can duplicate. We had more than one apple, more than one banana. Can you add the same item twice? What's this going to return? So you can do this. Notice we already have Starbucks coffee in there. So the question is, if we added it again, is it going to be there a second time? The answer is no, because this line is not actually adding the same item twice. It's taking the index Starbucks, the key Starbucks, which is already in there, and it's assigning the item coffee, right? So basically you're just repeating what's already there. Can we add the same key with a different value? So if we add Starbucks tea, that's going to create Starbucks coffee and Starbucks tea. Can we do this? Yes, we can do it, but it didn't add it twice. It just reassigned the value of Starbucks to tea. So the point here is that no, you cannot add the same key with a different value. Keys must be unique. Can you add a different key with a duplicate value? So we already have oh, we didn't have. Let's see. Let's add Coke and Pepsi. Can we do this? The answer is yes. So values do not need to be unique. So you can have Coke, which is a cola, and Pepsi, which is a cola. Well, we already saw that Starbucks and Piala are both teas as well. So okay, let's pop Coke a couple of times. Okay, so you can pop it once, but if you pop it when it's no longer in there, it's going to return a key error, meaning that Coke is no longer in the beverage. It couldn't find it, so it couldn't pop it. Okay, but let's update. The update function allows you to update the dictionary with a key value pair. So remember here, when we output items, we were returned a list of tuples. So the update function allows you to enter in a list of tuples as well. So here is a list with a tuple. So I could add more tuples in here if I wanted, like well, for now, what's a fancy kind of water? Perrier. Okay, so now Coke as a cola and Perrier as a water have been added, updated. We can update again. Here's oh yeah. Oh, I just wanted to show you one. I'll show you this. Okay. You can update twice, right? Okay, so with multiple items. Okay, so Sprite is a soda, Fiala, Starbucks are teas, Pepsi and Coca Colas, Perrier is water, Jack Daniels is whiskey. Okay, we also have the clear function, which removes everything like that. Same news with copying. So if we create beverage as this, and then we save beverage using the assignment operator equals. Now, if we pop Coke, beverage does not have Coke, but beverage 2 does not have Coke either. Right? But if we use the copy function, right, and then we pop Sprite from beverage 2, now beverage 2 does not have Sprite, but beverage does, right? So the copy function is important. If you use the assignment operator and then you change one, the other will also be changed. But if you use the copy function, then when you change one, the other one will not be changed. We already verified that index slicing doesn't work, right? It's unhashable because index slices don't work because it's not numerically indexed. If you want to see items, you can run them like this. I think I'm gonna just I don't think this is important. Right, and remember, if you use this assignment operator and then you clear beverage 2, the beverage 1 will also be cleared, right? So again, be careful with this assignment operator and when you're removing and clearing elements. Okay, a few, and we have about 13 minutes left. So let's do some exercises with dictionary. I'm going to reinstantiate beverage here. Let's add Sunkist to the beverage, and it's here. Let's add Sunkist as the key and orange juice as the value. Let's add this to beverage. A couple of ways we can do that. So I'll wait for your codes in the chat. Thanks. I'm going to plug in my laptop real fast. Okay. Right. So great. So we've got this was suggested. So that's right. We can add Sunkist as a key, and then orange juice as a index. Sorry, as a value. So we can do that. And then verify that Sunkist has been added. Okay. Another way to do that, right, would be use the update function. But it has to be, the function has to use a list of tuples. So a lot of, parentheses here, and that would work as well. Okay. Let's create a list of all beverage names in beverage. Great. So let's do these next few. Here's one. Create a list of beverage names and beverage types. Let's test whether we have a tea among our beverages. Let's remove Coke from the beverage list and test whether Coke is among our beverages. Great. Perfect. So I'm going to go through these a little bit quickly. If you are following this along later in a video, like just go ahead and pause as you try these yourself. So bev list equals bev, bev names equals bev, and we're going to use keys here, a list of keys. And we have to cast that as a list. Similarly, we can do beverage type. The important keywords to remember here are the names of the functions, so keys and values. Okay, test whether we have a T among our beverage types. How can we test whether a T is in our beverage type? So we can use the in operator, just like we did earlier, and see if T is in there, and it is. How do we remove Coke from the beverage? So what was it? Oh, we can pop. There's no remove. Okay. We can verify that the okay. And can we test whether Coke is among our beverages? Great. We can see is Coke in beverage keys. And here it's not. Right? So beverage keys, a list is going to give us the list, right, of beverages. Here. Right, and then we can verify that Coke is not in that list. Great. Okay. let's move on to some complex data structures. So we can do lists of lists. So we have fruits and we have vegetables. Before we were doing produce, we were doing fruits plus vegetables, right? And that concatenated those lists. But what if we make a list of lists? So you can say produce as fruits and vegetables like this. And this looks different, right? So here, when we concatenate fruits and vegetables, that puts everything into a single list. Creating a list of lists preserves the list structures. So produce now, let's answer some of these questions. How many items are in produce? What do you think?
2.
That's right. There are 2 items in produce. There's one list and there's another list. How many cabbage are in produce?
0.
0.
Right. Kind of a trick question. So produce only contains 2 lists. It doesn't contain any strings, right? So I should put this here. Okay, how many veggies are in our veggie list? So we can test it like that, but if I want to test it in produce, I'm going to do this and I'm going to index like this, right? So I can index produce 1, that's my veggie list, and the length is 3. Are cabbage among my veggies in my produce list? So use the produce list to test. So produce 1 is going to return my veggie list, right? And if I want to test if cabbage are among them, then I can check like this, cabbage in produce 1. Yes. Okay, I want to add some tomatoes to my list of veggies. Use the produce list to do this. So if I want to add tomatoes, how am I going to do this?
Produce is equal to produce 1 plus tomatoes.
Okay. Maybe let's say I have 2 tomatoes. Okay. And now if I check my produce, now my produce list has 2 additional tomatoes. Another way to do this would be append. And if I do that, that should also append in place. And that should have added a 3rd tomato to the list. What if I want to remove bananas from my fruits?
Produce 0 pop bananas.
I think pop doesn't work like that for lists, right? So pop you can only use an index or the last one. So I think for lists we have to use remove. And did this remove all of them? No, we still have 1 banana left, so we can run that again. And now we have no bananas. Okay, how many total fruits and veggies do we have? So I'll give you a second. What kind of a statement can we do to test this? So there are two expressions. One thing you could do is length. So if you do length produce, that's just going to give you 2, right? But you can do length produce 0 plus length produce 1. And that'll tell you how many total you have. Another way okay. Another way is you can just concatenate these. And we can do that, and it didn't actually change produce because we didn't save that concatenation to the list itself, right? So produce is still the same, but you can either concatenate and then take the length, or you can take the length of each. Right? So there are a few more exercises here. Lists and dictionaries. So we look at lists of lists. You can also nest lists inside of dictionaries, and you can nest dictionaries inside of lists. I'm going to use these. I'm going to end our tutorial here today, but we can you can try these at home as homework, and I'll cover these at the beginning of tomorrow's tutorial. Okay, I'll answer that one tomorrow. All right. Or let's do this now, since we have the question. One of the questions is asked, is it possible to get a precise number of tomatoes, reducing the amount from 3 to 1? Okay, so we can definitely get the number of tomatoes, right? So we can do that using produce 1 count tomato. Right? And that's 3. And then if we want to reduce the amount from 3 to 1, right, then we would need to do produce 1, remove tomato, and count. So if we do that, it's 2, and if we run it again, we're down to 1. Okay, so that's all for today. Any last minute questions? Okay, I'm gonna stop sharing and stop recording. I'll save this. I'll upload this link to the GitHub and Moodle, and I'll see you guys tomorrow morning.